effect of number of stimuli. It is really important. How the number of stimulus affects. Basically, we divide it into two broad categories. If we are applying two successive stimuli, the second category is the if we are applying multiple stimuli. In case of two successive stimuli, we have two specific phenomena: the beneficial effect, which is also called staircase phenomena, trapeze phenomena, or Bowditch effect. The second property is the summation. The first one is the beneficial effect. Second is the summation property. If we apply two successive stimuli, and in case of multiple stimuli, the properties are shown are the fatigue, clonus, and tetanus. Now come to the beneficial effect. So in case of beneficial effect, if two successive stimuli are applied to the muscle in such a way that the second stimulus falls after the relaxation period, that is really important. We are applying second stimulus, but after the relaxation period. So here we will observe or have two separate curves. Two separate curves are obtained, and the force of contraction in case of second stimulus would be greater than the first one. Here we are calling it beneficial effect. Now come to this graph. This is the point of stimulation. Here we are having a simple muscle curve or simple muscle twitch. This is the contraction and this one is the relaxation. We are applying second stimulus after the relaxation period. Then again there will be a muscle twitch or muscle curve would be generated, but it will have a higher intensity. We are calling it beneficial effect. In previous classes, we have studied a trapeze phenomena or staircase phenomena or Bowditch effect. Because if we apply stimulus in less than 10 seconds, then there will the magnitude of the first 3-4 contraction progressively increases. For initial 3 or 4 contractions, the magnitude of these contractions increases. So there is a formation of staircase in this graph. The amplitude of contractions is increasing continuously. So there is a formation of steps or stairs. We are calling it staircase phenomenon or the beneficial effect. Now come to the why muscle shows such kind of property. Basically, this staircase phenomena or trapeze phenomena in German word, the trapeze means steps. That's why it is also called trapeze phenomena. Bowditch first observed this property in frog's heart, this phenomenon in frog's heart. Then it is also called Bowditch effect. When the second contraction occurs during the relaxation of first one, then the amplitude of the second contraction or twitch becomes larger than the first one. There is a formation of steps. This is the trapeze phenomena or beneficial effect. The reason behind this trapeze phenomena or Bowditch effect is the amount of calcium which released during first contraction but not pumped back into the sarcoplasmic reticulum as a second stimulus applied within 10 seconds. So some residual amount of calcium left, which is used in case of second stimulus. So there is an additional quantity of calcium available for the second stimulus, and this second stimulus generate higher force of contraction than the previous one. So in graph, the next twitch or curve shows higher amplitude for few contractions. This is called Trappe phenomena or beneficial effect or Brodich effect. Now come to the second effect. If we apply two successive stimuli, this is called summation. So it is a process by which multiple muscle twitches or muscle contractions combine to produce more forceful contraction. Basically, this one is the contraction period and this one is the relaxation period. But in case of summation, the second stimulus is applied in relaxation phase. So here the curve is starting from there and achieving higher amplitude and completing its relaxation period. In case of beneficial effect, the second stimulus was applied after the relaxation period and the second curve is higher than the first, but the stimulus was applied after the relaxation period. In case of summation, stimulus is applied during the relaxation period of first curve. If we will apply stimulus here, then the second curve would start from here only. So the curve would be in this form. In Trappe phenomena, graph was observed like this. But in case of summation, because we are applying second stimulus in relaxation period only, so the second graph would start from here only. So here we are having a wave. This is a wavy summation. It is also called wave summation. If we will apply more than two stimulus. There are different types of summations. Here we are discussing only multiple fiber summation and the frequency summation. In frequency summation, basically frequency of contraction is increased. Frequency of contraction means in a shorter duration we are giving more number of stimulus. In case of multiple fiber stimulation, the number of motor units which are contracting simultaneously are increased. In the number of motor units is increased, then it is called multiple fiber summation. And if the rate of or the frequency of contraction is increased, then we call it frequency summation. There are the different types of summations. Here we discuss multiple fiber summation and frequency summation. This graph is of staircase phenomena and it is shown in case of summation. Here we are applying more than two stimulus. Now come to the clonus. We are calling it incomplete tetanus. Basically, in Trappe phenomena or staircase phenomena, basically we were giving 5 to 6 stimulus per seconds In case of clonus, the rate of stimulus it is around 10 to 20 per second. So the graph is achieved in this form. This is called clonus or incomplete tetanus. In previous slide, we also drawn a diagram or graph by summation. In incomplete tetanus, it is almost similar, but here frequency is increasing in case of incomplete tetanus. Now from here, if we will increase frequency further, then the graph would be generated in form of complete tetanus. This will be the graph of complete tetanus. Basically, we are increasing the frequency or the rate of stimulus. Different graphs we are achieving, or we are having different types of graphs. In case of Treppe phenomena, this was a graph observed. In case of summation, and if we increasing frequency further, then we will achieve such kind of graph, and we call it incomplete tetanus or clonus. And again, if frequency is increased, then there will be a tetanus. This condition is called tetanus or complete tetanus. Clonus is called incomplete tetanus. This is the summation, and this graph is of the staircase or Treppe phenomena. This is the tetanus. So sustained contraction of muscles due to repeated stimuli with higher frequency. Finally, we are applying a frequency of 25 to 30 per seconds. So such kind of, because these successive contractions so rapid, so they fuse together and the whole muscle contraction appears to be completely smooth and continuous, and we call it tetanization. Like if I will draw a graph, because contraction, the frequency of contraction, it is so fast in number, so we are achieving a graph which is observing as a smooth line. This smooth line, we call it complete tetanus. In case of clonus, we are achieving such kind of graph where frequency was less than the complete tetanus. In case of summation, frequency is less than the clonus. And in case of Treppe, the rate of the frequency of contraction was around 5 to 6. In this graph, we can observe the differences between these properties easily. This is the simple muscle twitch or curve, latent period, point of stimulus, point of contraction, contraction period, point of maximal contraction, relaxation period, point of maximum relaxation. This is a simple muscle twitch or muscle curve. This one is the summation, because second stimulus is starting from the relaxation period of the first curve. This is the incomplete tetanus, where frequency of contraction is increased due to increase in number of stimulus. And in case of complete tetanus, frequency is quite higher than these. Basically, we studied about the tetanus term, but this tetanus term it is different than the term of pathological tetanus. So spastic contractions of different muscle group in pathological conditions. It is caused by the Bacillus Clostridium tetani bacteria, which is found in soil, dust, and manure. This disease affects basically the nervous system, and its common features are the muscle spasm and paralysis. The first appearing symptom in the spasm, the muscle spasm basically first appears in the jaw muscles, or we call it locking of the jaw. Therefore, tetanus is also called lock jaw disease because the first symptoms are basically observed in jaw muscles. And this pathological tetanus basically caused by the Clostridium tetani, which is found in the soil, dust, and manure. In previous slides, we studied about the property of shown by the skeletal muscles called tetanus. And here we are discussing about the pathological term tetanus, which is caused by the Clostridium tetani bacteria. This graph shows the differences between Trappe phenomena, clonus, and tetanus. Because in this Trappe, second stimulus is applied after the relaxation period. In clonus, the second stimulus is applied in between the relaxation period, and in tetanus frequency is so higher in number, then we are having a flat curve. Now come to the next property, which is the fatigue. So decrease in muscular activity due to repeated stimuli. Due to repeated stimuli, because we were having two categories. The first one, if we are applying two stimuli, then we were observing summation and the beneficial effect. But if we are applying more than two stimuluses, then we observed clonus, tetanus, and here we are having fatigue property. When stimulus are applied repeatedly, after some time the muscle does not show any response to the stimulus. This is called fatigue. Now come to the various causes of fatigue. It could be due to exhaustion of acetylcholine. In previous classes, we studied about the sliding mechanism, where we studied the role of acetylcholine in case of muscle contraction. So this repeated stimuli is causing repeated contraction of muscles, but now there is a complete exhaustion of acetylcholine. Further, there is no availability of acetylcholine. That's why muscle shows fatigue. Accumulation of various metabolites like lactic acid, phosphoric acid could also be the reason for fatigue. Lack of nutrients like glycogen, or also the reason lack of oxygen. These are the various causes which is responsible for the fatigue. This is the curve which is observed in case of fatigue. This is the point of stimulation, latent period, simple muscle twitch. Again, we are providing stimulus. Still, we will observe curve. But due to repeated stimuli, the strength of contraction is decreasing. Finally, there is no contraction. This is the fatigue curve. The various effects in temperature. So what could be the results in case of muscles? In case of warm temperature, if it is around 40 degrees Celsius, the force of muscle of contraction is increases, because excitability of muscle increases, chemical process involved in muscle contraction are also accelerated, and viscosity of muscle decrease due to warm temperature, which is having around 40 degrees Celsius. So this temperature causes excitability in muscles. The chemical process involved in muscle contraction are increased or accelerated, and the viscosity of muscle decreases. Now come to the effect of higher temperature. At higher temperature, if the temperature it is around 60 degrees Celsius, then the muscle develops heat trigger. We are calling heat trigger. It means the shortening or stiffening of muscle fibers. And if temperature is so high, then there is an irreversible phenomena which is shown due to the coagulation of muscle proteins. Basically, in muscles, there are actin and myosin proteins. So these muscles proteins got coagulated, and an irreversible phenomena, that is a heat trigger, is shown by the muscles. If there is a higher temperature, now come to the other types of trigger which are dependent on the various temperatures. If temperature is less, then there is a cold trigger due to exposure of severe cold. That is also a reversible phenomena. Calcium rigor, which occur due to increased calcium content, it is also reversible. Rigor mortis, basically it develops after death, because after death there is no availability of ATP, so muscles cannot relaxes easily. That's why muscles become stiff after death. Now come to the muscle tone. It is defined as a continuous and partial contraction of muscle with certain degree of vigor and tension. This is the definition of muscle tone. We are defining as the continuous and partial contraction of the muscle with a basic degree of vigor or tension. This in skeletal muscles, this minimum contraction is neurogenic in nature because there is a continuous discharge of impulses from gamma motor neurons in anterior gray horn of the spinal cord. These gamma motor neurons in spinal cord are controlled by the higher centers of the brain. So due to regular discharge of impulses from these gamma motor neurons, skeletal muscles always are in contraction state, but it is of partial nature, and this is called muscle tone. And this muscle tone, basically it is controlled by the higher center of the brain through the gamma motor neurons. In cardiac muscles, this muscle tone, basically it is myogenic in nature because cardiac muscles control their tone self. It is not under the nervous system. Definitely it is influenced by the nervous system, but this tone is not directly generated by the nervous system. In smooth muscles, it is also myogenic in nature, and it depends upon the calcium level and number of cross bridges in case of smooth muscles.